Hello friends, today I will discuss about impact of floating neutral of three-phase transformer in case of distribution system. Before going through this video, you can go through my channel and do subscribe my channel, and also press bell button for notification of videos to be uploaded in future. Now in distribution system, the transformer rating is 11 kV by 415 volt, that is HV side is 11 kV and LV side is 415 volt. In the HV side, most of the cases it is star connected, or it may be delta connected for few cases, and in the LV side it is star connected, and the neutral of the star side of the transformer or LV sides of the transformer is connected to earth in the supply side or in the source side. Now for taking the consumer load, the connection is shown here. H1 is one consumer or one of household, and H2 is another household, and H3 is another household. H1 is connected from red phase and between red phase and neutral, and H2, that is household 2, is connected between yellow phase and neutral, and household 3 is connected between blue phase and neutral. Most of the domestic load is single phases, that is one of the phase is taken to the domestic load and neutral wire is taken to the domestic load. But for bulk consumer, three phase load is taken from the supply. Now since the LV side is star connected and phase to phase voltage is 415 volt, the phase to and the neutral wire is connected to earth in the source side or supply side, the phase to earth or phase to neutral voltage is 440 volt and neutral point voltage is 0, as the neutral is connected to earth in the source side. Now if the neutral is not connected to the earth, the voltage of the neutral point is undefined, that is the phase to neutral voltage is here 240 volt, but phase to phase voltage is 415 volt. But what is the voltage of the neutral point? If it is a balanced load, that is load of H1, H2, H3 is same, then the neutral point voltage is 0. But with respect to earth, the neutral point voltage is undefined, and this is why it is called the floating neutral, that is voltage of neutral point is floating. If any earth fault occur in any phase, the voltage of the neutral point comes to phase voltage, that is voltage of the neutral point can vary up to the phase voltage, and that is why it is called the floating neutral is under floating condition. Under normal condition, that is if the neutral is connected to earth, let's consider the earth fault occur in the blue phase to earth, and H3 is connected between blue phase to neutral. In this condition, the household supply H3 will be interrupted, but the other household supply, that is H1, is connected to red phase and neutral, and H2 is connected between yellow phase to neutral. There will be no problem in case of other phases, as the voltage will not overshoot as the neutral is connected to earth. But under floating neutral condition, as the neutral is not connected to earth, if earth fault occur in the blue phase, then the neutral voltage comes to phase voltage. In this condition, the household supply H1 and H2 will face phase to phase voltage or line to line voltage, that is 415 volt, and in this condition the equipment connected in the household H1 and H2 may fail, as high voltage is sensed by the equipment connected in the household 1 and household 2. As the equipment in the domestic load are designed for 240 volt supply voltage, since the under earth fault condition, under floating neutral condition, the H1 and H2 phase line to line voltage, that is 415 volt, this over voltage leading to failure of the equipment in the household 1 and household 2. Now again consider a case where the neutral is connected to earth, but the neutral is broken between consumer or domestic household H2 and H3, as shown is in this diagram. In this condition, under normal condition, there will be a problem for H2 and H3 as neutral is broken from the supply. That is, H2 and H3 may face high voltage under normal unbalanced load condition, but there is no problem for H1 as the H1 the supply voltage is 240 volt. Now let us consider the household 1, household 2 and household 3 load in terms of resistance R1, R2 and R3. Since the resistance is inversely proportional to the wattage rating, the more the load, the less the resistance, and less the load, more the resistance, as the wattage W is equal to V square by R. Now the neutral is broken for household 2 and household 3, and household 2 load is R2 and household 3 load is R3 ohm. So the household 2 voltage will sense a voltage of VR2 and household 3 sense a voltage of VR3. So VR2 is equal to R2 by R3 plus R2 into 415 volt, and VR3 is equal to R3 by R3 plus R2 into 415 volt as per voltage divider rule. If all the load, that all the household load is same, that is R1 is equal to R2 is equal to R3, then VR2 is equal to VR3. Since the VR2 plus VR3 is equal to 415 volt, so there is no problem for household 2 and household 3, as it will sense a voltage of 207.5 volt. Now if the load of the household 3 is greater than that of the load of the household 2, load is greater than that of the household 2, that means the resistance of the household 2 is greater than of the resistance of the household 3. Let's consider the load is connected such that the resistance of household 2, that is R2 is equal to 300 ohm, and resistance of the household 3 is R3 is equal to 115 ohm. Therefore the household 2 will be sense a voltage of 300 volt, and household 3 sense the voltage of the 115 volt. For household 3, the equipment connected in the household 3 sense the low voltage, and equipment connected in the household 2 will sense the high voltage. So under high voltage condition, the equipment may fail, as all the equipment in the household are designed for 240 to 250 volt. Now consider again the case of the floating neutral in case of HB side, that is 11 kV side. Now 11 kV side is star connected. If the neutral is not connected to the ground or earth, it is called the floating neutral. If any earth fault occur in any phases, let's consider earth fault occur in the yellow phase to earth, then the other phase voltage will overshoot to line voltage, and that will cause the failure of the equipment such as LA, burst force insulator, and also failure of the transformer. Now as in the HV side, as the line to line voltage or phase to phase voltage is 11 kV, and phase to neutral voltage is 11 by root 3, that is 6.3 kV, and under this condition earth fault occur in the yellow phase to earth, and red phase and blue phase voltage will overshoot to 11 kV, and And under this condition, all the equipment or the equipment connected in the red phase or blue phase, that is LA, BPI, may fail due to voltage overshoot due to earth fault occur under floating neutral condition. Now, for protection viewpoint, that is relay remains silent under earth fault condition when the neutral is floating. Now, under normal condition, the connection of the relay for a feeder is shown in this diagram. That is, for earth fault relay, all the CT secondary are connected, and that is all the S1 terminal of red phase, yellow phase, and blue phase are connected together and fed to one end of the relay, and all the S2 terminal are connected and fed to another end of the relay for earth fault relay. Now, any earth fault occur in any phase, for the feeder connected from the bus, the bus is connected to the source, that is the transformer. Here transformer is Y connected, and the star point, that is neutral point, is earth. If earth fault occur in the red phase to earth, then the neutral connected to the earth provide the return path of the earth fault. So, therefore, the red phase current will increase, and in the secondary side there will be unbalance in the earth fault relay, and the relay, if the relay setting is 0.1 to 0.2 ampere in the secondary side, and this the unbalanced current crosses this setting, then earth fault relay actuate and it will trip the circuit breaker to clear the fault. But under floating neutral condition, as the neutral is not connected to the earth in the star winding, there is no return path for earth fault, and during this condition the earth fault current will not flow, that is the red phase current will not increase, and that is why the relay remains silent under earth fault condition, and relay is unable to clear the fault, and therefore the fault remain in hanging condition, and the voltage will overshoot in the other phases until and unless the fault is cleared.